Hi, I'm Danny. Welcome back to another video. In today's video, I'm going to show you everything you need to know about completing a parasitic draw test successfully. If you have a battery that's having a hard time starting when you wake up in the morning, this could be your problem. I'm going to show you 5 different ways to complete this, including the old school method of pulling the fuses and some highly technical advanced methods that are new on the market. Let's get started. The easiest way to do a parasitic draw test is with an amp clamp. So I'm going to put this on, right now it's on volts mode. I just want to go over 1 and get it on the amp setting. And then I want to zero it out. So I want that to be 0. And then I'm going to hook it around both of these cables. Not just one, it has to be around all the cables. As I look at the meter, it's reading 1.35 amps. So that amp clamp is on the negative cable and it's reading all the current that's leaving the battery. And that's 1.35, 1.36 amps. So that's enough to make your car not start in 18 to 24 hours, maybe overnight, depending on the condition of your battery. Now I have the dome lamps on, so I could just show you something as simple as a light causes all sorts of problems. So let me shut one of them off. 790 milliamps. Now let me shut the other one off. And now it dropped to 180 milliamps. Using the amp clamp is a quick way to find a parasitic draw, and it works great if it's a ½ amp or more. But if you're looking for a draw that's 50 to 100 milliamps, there's a much better way. Let me show you how to do it. Using a multimeter to measure current draw is much more accurate, especially if you're looking for a draw that's 200 milliamps or less. But there is some preparation to keep them modules and computers from waking up. Let me show you what that is, and then I'll show you how to hook up the meter. First, roll down the window. Next, shut off the key, shut the door, and lock the car. It's a good idea to put the remotes 20 feet away from the car. That way the car doesn't accidentally wake up. If you think you need to get inside the car to check fuses, trip the latches. Doing this will trick the computer into thinking your doors are shut. If your hood latch has a switch, do the same thing to your hood latch. Now I need to wait for the computer and any modules to shut down and fall asleep. This could take up to 45 minutes, but on most cars, it's just 5 minutes. It's a good time for me to show you how to hook up the meter. Start by removing the terminal from the negative battery. Take your meter lead, the black one, and that's going to go on the terminal. Now your red one, that's going to go on the post. And as you can see, these alligator clips aren't going to be big enough for the post. By the way, these meter leads, I'm going to put a link to these in the description so you can use them this way, but when you need to clamp onto something, you actually have a clamp. But it's not big enough for this battery, but we're going to go ahead and use a jumper here. And then we'll hook it right here. This next step is pretty important. All this is a jumper wire. I'm going to put one in right here and the other end right here. Basically the same place that the meter leads went. Let's put the meter in the amp scale and just make sure it says DC current, not AC. So we're going to take our meter leads. The black lead is going to go in the COM section. And the red lead is going to go into the 10 amp scale. So as soon as I plug this in, all the current that's coming out this negative post is going to go through this meter lead. It's going to come here. It's going to go inside the meter. It's going to get red. Then it's going to come out on the black terminal. And then it's going to go back into the car, and that's going to power up any components that are left on. So you're going to see some current up here as soon as I plug this in. And there we go. That's 248 milliamps. But remember I put this jumper wire, so that's taken some of the current. So now I'm going to unplug the jumper wire. So it's reading 1.19 amps. On a healthy vehicle, you should only see a 20 to 50 milliamp draw. I'm seeing over an amp. The reason? I left the courtesy lights on in my last test. Let me go shut those off one by one and we'll watch the current drop. So here's the first courtesy light off. And then here's the second one off. Now I'm going to switch out the Veneri meter with my fluke meter for two reasons. One, I just wanted to show you that this test can be run with an inexpensive meter. You don't need a really quality meter for this test. The other reason is I'm going to need an extra meter when I show you how to find the parasitic draw in my next test. So I need to put my jumper cable back on the cables, and the reason I use these is because if I hook up the meter without using this, the initial inrush current could exceed the 10 amp rating on my meter, and then that's going to blow my meter fuse. So we're just going to switch it off here, put this in common, and then all I got to do is pull the jumper lead back off. And there's our current reading. And it's about the same as what this meter was saying also. So pretty accurate meter. If you're not sure how to read milliamps on a meter, just ask Siri. Hey Siri, how much is 0.500 milliamps in amps? It's a half an amp. Now I'm going to show you exactly how to find the circuit that's draining your battery. I've turned the courtesy lights back on to simulate a real-world condition. The meter's reading 1.1 amps right now, and I'm going to show you 4 different ways, from the old school way of pulling fuses to some modern day technology. Let's get started. So first up is the old school way of just pulling fuses. So how this works is you just start pulling fuses one by one until you see this current drop or go away, and that'll be the circuit that fuse is controlling. The problem with this is on the newer cars, they have so many computers and body control modules that each time you pull a fuse, it'll wake up one of them modules, and then you'll have to wait 3 to 5 minutes. So this could turn into quite a few hour job. So the next way to do it, you're going to need another meter, and it's going to be in the voltage scale, or millivolts would even be better. So you just take your meter leads and you touch each test point of the fuse, and what you're looking for is voltage there. So that had no voltage. This one has no voltage. And this fuse has 12 millivolts. So this way, you're not going to wake up any modules when pulling fuses because you're not pulling them. You're just reading the current that's going through it. So this is the way that a lot of the technicians use on the newer cars. So the only issue with this way is you got to know how to convert those millivolts to milliamps. Let me show you another way. This is a thermal imaging gun. These things work good if you have a higher current draw. And your engine has to be cold. So if I hold this up, I can actually see the fuse that's showing the current that is going through it. So it's reading the heat. But this only works good when it's probably an amp or more. Otherwise, some of that current is just too small for this gun to pick up. Now the final way to do this is with an Amp Hound 2. So the Amp Hound 2 is specifically made for parasitic draw testing. So it works kind of like the way I showed you with the meter, where you measure the millivolts. But what this does is it actually takes those millivolts, it converts them for you, and it shows you the current draw. So it's the same setup. You go on each test point of the fuse, and it's going to give you the current draw, not just a millivolt. So it converts it for you. The problem with this is you got to buy the tool, but the tool does work really good. I have a full video on this tool, and I'll put a link to that in the description. Once you determine the fuse that was causing that current draw, you're going to need to find a schematic of that circuit. There's no way for me to go any further to help you out. If you like this video, give it a thumbs up and consider subscribing. I'm going to put links to the tools that I used in the description as well as related videos. Don't wanna